Hello, welcome to another lecture from the 2020 Honors Chemistry Short Lecture Series. My name is Regina Yanez. A fun fact about me is that I love food, but what I do not love is fraudulent food. In today's presentation, I will be talking about food fraud and two different types of it. This was inspired by the following CNN article, Momentum Builds to Keep Fraudulent Food Off of Stores' Shelves. Since there are many different types of food fraud, I have decided to talk specifically about adulteration and contamination of food. These are very important types of food fraud. Throughout the presentation, it will become clear why these two are very important, how they affect our health, and what today's scientists are doing to help in this matter, especially the tools they are using. This is my presentation.
Food, as we all know, is essential to life and our health. People routinely go to the grocery store, choose and buy their groceries, cook them, and then of course eat them. Many people, however, are unaware that not everything is what it seems. Just like any other type of fraud, there is also food fraud. Food fraud has been around for some time, but was always seen as a minor concern. The concern for it has been growing throughout the years. Many of us go to specific supermarkets because we trust that our go-to grocery stores have the best and safest products to offer us. This might not be true, but it isn't their fault. Many times, it starts as early as in the farm life to as late as the packaging, shipping, and storing of the product. Throughout the presentation, I will be talking about the CNN article that inspired this presentation. I will be explaining food fraud and two major types of it: adulteration and contamination. Then, I will be talking about two techniques used to detect the contaminants in food. According to the CNN article, Momentum Builds to Keep Fraudulent Food Off of Store Shelves, food fraud is a big problem, and it is dangerous to human health. For example, in 2008, scientists tested baby formula and found it was laced with melamine after many babies died, and about 30,000 were found very sick, almost dying. In 2013, a few workers at suppliers for a few restaurants admitted to mixing out-of-date meat with the fresh meat and selling the product as if it was entirely fresh meat. This incident led to testing the meat for horse meat and phenylbutazone, a painkiller used in horses which can be toxic to humans. That same year, U.S. Customs and Border Protection seized just $200,000 worth of fake foods. There was also a calculation made about fish samples in retail outlets in the U.S., and 33% of fresh caught fish were labeled incorrectly. The article also stated that a lab in Newark, New Jersey found and identified pork and beef in supposedly vegetarian soup mixes and tomato sauces. It was also estimated that about 48 million people get sick from food-borne diseases each year. What is food fraud? According to FSNS, Food Safety Net Services, food fraud is the act of purposely altering, misrepresenting, mislabeling, substituting, or tampering with any food product at any point along the farm-to-table food supply chain. There are many different types of food fraud. All types, however, are affecting factors to our health in short and long terms. The first type of food fraud I will explain is adulterated food. Adulterated food is food that is impure, unsafe, or unwholesome for people to eat. This unsafeness in food happens when non-nutritious substances are added to food in small amounts and quantities to improve its appearance, flavor, texture, and/or for longer storage life. Three very common adulterated foods are milk, saffron, and seafood. On the chart, you can see that milk and saffron are in the top three most adulterated foods. The top adulterants in milk are water, whey, cane sugar, soybean oil, melamine, and formaldehyde. Melamine is a white crystalline chemical often mixed with formaldehyde, a low-cost preservative. These are mixed to create a resin very similar to a plastic. It is added illegally into milk to increase its protein content and to preserve it for longer. People who had been ingesting milk noticed health issues like renal failure and kidney stones because of the melamine-laced milk. Saffron, a commonly used spice, is the third most adulterated food. It is adulterated by many different plants that can easily be mistaken for real saffron. For example, marigold, arnica, calendula, turmeric, annatto, etc. Many times, however, one of its adulterants is red 2G. Red 2G is a synthetic red azo dye. It is found in many foods like meat and sausages for a fresher appearance, and in many candies too. It is also recommended to avoid this red dye as much as you can, since it can cause cancer according to EFSA, European Food Safety Authority. Seafood is another very common adulterated food. Many times they mislabel or purposely give cheaper fish for the same price as if it was the actual fish. Many give Asian catfish instead of grouper, tilapia instead of snapper or tuna, catfish roe instead of beluga caviar, and pufferfish instead of monkfish. Pufferfish is the most concerning of these adulterants. They have toxins in their liver called tetrodotoxins, which are poisonous and intoxicate humans. The next type of food fraud is food contamination. There are 4 main types of it: chemical, microbial and biological, physical, and allergenic. They are all equally important and affect our health. Chemical contamination is an accidental type of contamination. It becomes food fraud when the food becomes contaminated by a chemical substance. It can be contaminated before reaching the kitchen. For example, through fertilizers, pesticides, or persistent organic pollutants. It can also be contaminated once it reaches your kitchen through cleaning chemicals, chemical residue, or natural toxins. Microbial, also known as biological contamination, is the most common reason of the 4 types of contaminants behind food poison outbreaks. Microbial contamination occurs when food has been contaminated by microorganisms. A microorganism is a microscopic organism like a virus, fungus, or bacteria. Bacteria like Campylobacter, Salmonella, Listeria, and Escherichia coli are types of poisoning people get from food. These are serious illnesses and can be more dangerous to certain people. Other examples of this contamination are toxins and mold. Physical contamination is contamination mainly by the person cooking the food or serving it. It is when the food comes in contact with and is contaminated by a foreign object. Examples are hair, plastic, jewelry, small bugs, or even the different phases of food processing, like its packaging, transportation, or storage. The last type of contamination, and least considered, is allergenic contamination. It is a contamination that occurs when a food that causes an allergic reaction comes into contact with another food. The 14 named allergens are gluten, sesame, nuts, crustacean, eggs, fish, mustard, milk, celery, peanuts, soya, shellfish, lupins, and sulfite. To detect all these different contaminants, special tools, techniques, and methods are used. Throughout the years, scientists have been developing many techniques that improve the accuracy of scanning each food product for any signs of contamination or adulteration. 2 techniques I will be explaining are the FTIR, Fourier transform infrared analysis, and the NIR, near infrared spectroscopy. The FTIR, Fourier transform infrared analysis machine. According to Foss, FTIR analysis is a spectroscopic technique that makes use of the naturally occurring electromagnetic spectrum defined by the wavelengths between 2,500 nanometers and 25,000 nanometers. It studies the interaction between matter and infrared radiation. Infrared radiation is electromagnetic radiation or light with a longer wavelength than visible light. The main use for the FTIR machine is to detect undesirable microorganisms in finished food products. Richard Mills, a scientist at FOSS, stated, "The FTIR is not a total solution for all food fraud. It works best for liquids foods such as milk." At FOSS, they use the FTIR to screen milk and scan it for any abnormalities. It also provides accurate spectral fingerprints of each sample under analysis for easier detection. How FTIR works. First, there is infrared light from a fitting source. That light is then directed at the sample being tested. Some light will be reflected, but a larger fraction of the light will travel through the sample. Specific parts of the light, however, will be absorbed by the sample material. The part of the light that is transmitted, which is the part carrying the molecular information of the sample, can be collected by the detector. The detector produces an electronic signal which is then turned into a spectrum. To get to the spectrum, you need to get rid of environmental influences like carbon dioxide or water vapor that might show in the spectrum. First, a spectrum without a sample present needs to get measured. The signal it gets is called raw since it has no sample present, and it is then Fourier transformed into an infrared plot of light intensity versus the wave numbers. This IR plot is used as a reference spectrum. Then the same procedure is done, but this time with the sample material. You get the IR plot for the sample material and combine both spectrums by dividing the sample spectrum by the reference spectrum, which gives you the FTIR transmission. This FTIR transmission spectrum then gives you the spectral fingerprint to determine the adulterants or contaminants present food samples. NIR, near-infrared spectroscopy. According to Abrego, NIR is an analysis technique for fast, accurate food testing. It measures food content, food ingredients, food additives, stabilizers, and so on. NIR is a convenient technique compared to the others because of its simple use and low cost. The NIR technique is usually used for solid samples, while the FTIR, mentioned before, is used for liquid samples. There are two processes that can be used: the reflectance process or the transmission process. The process you use depends on what you want to analyze. How the NIR works. The reflectance process involves reflecting light from the sample, measuring its absorbent qualities by how much light is reflected back. With transmission, the infrared light passes through the sample, measuring how much light the sample absorbs. Different compounds display different infrared colors because certain molecular bonds absorb distinct infrared light wavelengths. This information is then converted into data and used in the comparison with other food samples. In conclusion, food fraud is a real and everyday problem, whether we notice it and do something about it or leave it be. The ingestion of adulterated and contaminated foods affect our health in one way or another. Although everyone's body has a different reaction to what they eat, there is still a reaction. Analytical scientists, for that matter, have taken on the job of trying to reduce this problem and get rid of it completely. They have been testing food samples for any adulterants or contaminants that might not be obvious. Many food companies have adopted these techniques for better quality food and safer products. Many more techniques are being developed and for any different type of foods or food products for our health and safety.